Welcome to qnawire.
In this problem, we have to find the ratio between the angular acceleration of the second hand on the clock and the angular acceleration of the minute hand on the clock. Now, we're not really given any information apart from the fact that they're the same length, but we actually do know some other crucial information that will help us solve this problem. The period of a second hand is 60 seconds, right? That's the amount of time that it takes for it to go once around the clock, counting off a minute. The period for a minute hand is going to be 60 times 60. That's the number of seconds in an hour. That's 3,600 seconds. Now, we know that the equation for angular acceleration is v squared over r, but we don't know a velocity. But now that we have the periods, that's easy to solve for. We know that t is 2 pi r over v, and so we can rearrange to solve for t and have it in terms of quantities that we either know or are going to cancel out. Let's start with the second hand angular acceleration. So I'm going to denote it with alpha seconds. That's going to be 2 pi r squared over t squared times r squared. So that's just v squared over r, but now in terms of t. And that's going to give us a final answer of 4 pi squared r over t s squared. Now, when we do the same thing for our minute hand, we're going to have exactly the same equation as we did up there, just this time it's going to be in terms of the period of the minute hand, tm. And we're told that the radius is the same, so I'm not going to denote them any differently. All right, so now let's figure out our fraction. We have alpha s over alpha m. We know that's equal to 4 pi squared r over ts squared all over 4 pi squared r over tm squared. Now, as you can see, everything is going to cancel out except our two periods, and that's going to give us tm squared over ts squared. Now, from there, we can plug in. We said that our minute hand period was 3,600 seconds squared, and our second period was 60 seconds squared. When we do it that math, we find that the relationship between the two is 3,600. And that's going to be the answer to our question, the relation between the angular acceleration